Let's talk now about Dockerfiles. A Dockerfile is a plain text file that contains commands primarily about what software to install inside of the Docker image. This is the more trusted and transparent way to build Docker images as opposed to doing it through an interactive method. Once we have created a Dockerfile, we can use commands from Docker, primarily Docker build, to build this file into a Docker image that we could then use to run a container. Docker images are built in layers, and as such, Docker files always start off by specifying a base Docker image that the new image is to be built on top of. And most Docker containers used in data science are Linux containers, and therefore we use Linux commands to install software. So if you're not familiar with using Linux, there's something that I just want to draw your attention to, and that there are different flavors of the Linux operating system. So there's Ubuntu, Debian, CentOS, Red Hat, for example, and several more. And when you're using the install commands, you have to use the right kind of install commands based on the flavor of Linux container that you're going to use, or Linux operating system. In this course, we're going to focus on using only Ubuntu and Debian flavored images, and therefore we'll use the apt or apt-get tools to install our programs. Let's now talk about a workflow for building a Dockerfile. As you know from setting up your own laptop with your data science stack, it can take a long time. And if things don't go well, it can take a really long time. So since building Docker images from Dockerfiles is really about installation and installing things inside of a Linux container, if you don't do this efficiently and effectively, you can end up spending a really long time on this and troubleshooting it. So here is how I do these things. This is my workflow. So first you start with a base image to build off of, and there's lots on Docker Hub. Later in the lecture I'm going to point you to some good starting places and talk about how you decide what is a good starting place. After that, you're going to create a Dockerfile, and you're going to name it Dockerfile, and you usually save it in the root of your project. And in that file, you're going to start off with from, and then the name of the image that is going to be your base image that you're going to build off of. So what that means is that the image that you're going to build up in your Dockerfile is going to inherit everything from that base image, and then you're going to add some things on top of it. Then you want to launch or run that base image interactively in the bash shell on your laptop so that you can play around with and try out the install commands that you think will work. And sometimes they won't work, and so you'll have to interactively edit them and try again. And when you find a command that works, then you're going to add that to your Dockerfile, and you're going to put the word run before that and save the Dockerfile. Okay? And then after you've added a couple commands to your Dockerfile, then you should stop doing things interactively, open up a new terminal, and try and build a Docker image from that Dockerfile. And you'll do this using the following command: docker build, and then --tag, so you can give it some sort of temporary image name, and then the path to the Dockerfile directory that it lives in. If it's just in the directory that you're working in, then you can just put a dot there to say current working directory. And then once the entire Dockerfile works from beginning to end on your laptop, then you can move to building it remotely. And actually, I need to update these notes. This says a trusted build on Docker Hub. We're going to say a trusted build on GitHub Actions this year, which is now my new preferred workflow for building and distributing Docker images. Now, one thing I want to point out before we go on to do a demonstration of this is that you are going to iterate over steps 3, 4, and 5 several times, okay? So you're going to work interactively on a command, add it to the Dockerfile. Work interactively on figuring out a command that works, add it to the Dockerfile. Work interactively on a command, add it to the Dockerfile until when you hit 2 or 3, and you're going to try and build it. Then you're going to add some more things. So you're going to go back to working interactively to try and install command, and then add it to the Dockerfile when it works. And then do this process a couple more times, and then build it try and build it again from the Dockerfile. So this is going to prevent you from having a very long Dockerfile where you have an error, a third of the way into building the Docker image, but it's really hard to debug and figure out when that error occurred. By iterating over this and testing things out very frequently, you're going to figure out where you've introduced errors, and hopefully by playing around with things interactively in the terminal, you're going to minimize the errors that you put into the Dockerfile in the first place. So what we're going to do now is demonstrate this workflow by building a Dockerfile that we can use to build a Docker image that will have the R programming language and the Cowsay R package installed. We're going to start with a base image that doesn't have these things installed. So the one we're going to start with is Debian stable. Debian is a flavor of a Linux operating system that uses apt or apt-get to install things. And the first line, therefore, of our container will be from Debian stable. Before we start trying to write out a lot of commands in our Dockerfile, we're going to run it, and then we're going to try and install things interactively again, and when they work, we'll add them to our Dockerfile. And then eventually, we will build the whole thing. So let's go ahead and get started with this. Okay, let's get started on this demo. I'm inside my favorite editor, RStudio, but you can work wherever you would like. All you need is a text editor and a terminal to follow along. So the first thing that I'm going to do is create a Dockerfile where eventually I will paste commands in. So that's going to be a text file, and I'm going to save that as Dockerfile with a capital D. And I'm going to save it in the root of my project. Now, I had said that I was going to pick the Debian stable base image, so I start with from as my first Docker command, and Docker commands are always all uppercase, and then I'm going to write Debian stable. And that is the first command for my Dockerfile. Now, before I start to add more to this Dockerfile, in the terminal, I am going to open this up interactively, the Debian stable container, so that I can play around with things and make sure that they work before I copy and paste them into my Dockerfile. So I am going to say docker pull Debian stable, and if I don't have it locally on my computer, it's going to go to Docker Hub and bring the image down to from Docker Hub to my laptop, and that's what it's doing now. And now if I want to run it interactively, I'll say docker run --rm to make it ephemeral, -it to make it interactive, and then the name of the container, so Debian stable. And now I'm inside the container, and I can copy and paste my installation commands and test out if they work. So the first thing that you do when you're installing things on Linux is that you need to update the list of available software packages that the apt-get tool can access. So you do this every time you're starting to install things. So we'll say apt-get update. Next, if we went to CRAN and followed the instructions for how to install R on Debian, then we would see that we need to run apt-get install rbase, another package, which is rbase dev. So we wait and see if this works. We say, sure, let's continue installing these things. Looks like it's done installing and it was successful. So now we've had two commands that we've found out that we can have them work interactively. Let's add them to our Dockerfile and then see if we can build the Dockerfile, okay? So we can use the up arrow or type out the history to see what we typed in. So the first thing was apt-get update. And I have to precede any of these shell commands that I would like the Dockerfile to run with run, okay? So these are the things, anything that's preceded by run are things you would just type into the shell. Okay, so that was the first thing to update the packages, and then the second thing was installing R and the developer packages for R. So we're going to save our Docker file, and now we're going to try and use Docker to build our image. So the command for that, I'm going to exit out of the container, and I'm going to clear just so it's easy to see it at the top. I'm going to type Docker build. I'm going to type --tag, and I'm going to give it a name. So I'm just going to say test R1. And then I'm going to say, where does this live? Well, it currently lives right here in the project root. Okay, so let's see if we can build the Docker image. Oh, what happened? It failed. What's going on? Well, let's read the error message. It says, do you want to continue? Yes, no, abort. Oh, right. When we were installing things interactively, we had to click yes, or put a Y into the terminal for it to continue. So we need to manage this and handle this inside of our Dockerfile. So let's do that now. So we'll add -y here to the end of this line, and then we'll try the build again. And interestingly, it didn't have to redo the things that it succeeded on previously. This is the really nice thing about layering in Docker containers. It starts off basically where it failed out building last time. All right, it looks like it worked. Let's test it out. Let's open up this let's open up a container that's run off of this image that we just built and see if we can open the R programming language. So we're going to type Docker run --rm-it, and instead of running Debian stable this time, we're going to run the container that we just built, which was test R1, I think. So we're inside the container, and let's try and open the R programming language. And we're in R. This is fantastic. So now we have used our Dockerfile to build an image where we can have containers that can run the R programming language. So let's now work on installing packages inside of this R program, or inside of this Docker container. So we can, again, play around with how we would do this interactively. So if we were inside our studio, we would do install.packages, and then install some package here. But that's not going to work in our Dockerfile. We need to be installing these from the command line. So instead of that, what we're going to do is we're going to play around with this at the command line. Okay, so I'm going to use that R script trick that we were using for rendering our reports. So we're going to do R script, and we're going to echo, and then we're going to echo the install.packages. Okay, so install.packages, and let's install some really important package called cowsay that you have probably not met yet. And we can see that it worked interactively. So now we should check also. Actually, let's go into R and see if we can load it. So we can type library cowsay. This is double checking that things worked. We didn't no error. So this is very promising that things worked. So let's press the up command to find this, and we're going to add it to our Dockerfile again. So I'm going to add run, because this is something we'd run in the shell, and we're going to install the R package. So let's try and build an image again from our updated Dockerfile. So I am going to exit the container, and I'm going to do my Docker build command again, so which is Docker build --tag, and then I have to give it a name for whatever image I'm going to build. So let's call this test R2, and then I have to say, where is the Dockerfile? Well, it's in the current working directory. So let's try and build this, build a new image from this Dockerfile. Look at this again. It's really cool. Since we had already built an image that used the first 3 steps, when we build the image this time, it's so much quicker because it can just use the image from these 3 steps and add another layer on top of it. So this is like the power of layering in Docker is very cool. It's already done. So let's test this out now. So let's go back into the container. So docker run -rm-it, and then we have to give the name of the image. We called this one test R2. And let's go into R. Let's load the cowsay library. Hopefully it's there. It appears to be there. This is fantastic. And now let's run a command from this package. Yeah, this worked. So we now have a Docker image that was built off of Debian. It has the R programming language installed and the very important cowsay package when you want to give Unicode jokes and pictures to your friends. Okay, so that was a very quick, short demo of how you can build a Dockerfile or craft a Dockerfile so that you can build an image from it locally on your laptop. So here I'm trying to provide you with a command summary for the commands that you'll likely use in a Dockerfile. You can see I'm not giving you too many commands here because, to be honest, the commands are going to more come from things that you would type into the shell to install things than opposed to Docker. So with the Dockerfile, the most important command is going to be from, which has got to be at the very top of your Dockerfile, specifying what is the base image. What are you going to start? What is going to be your starting place, your starting ground that you're going to layer things on top of? And then you're going to put run commands on top of that, okay? And the run commands are, what follows the run commands are things that you would run in the shell to install things, okay? There are some other commands that maybe you will need to encounter when you're building a more complex Docker container or a Docker image that might be doing more complex things. So you'll see, if you went and looked at the Rocker tidyverse image that we were playing around with in our studio, or any of the Jupyter ones, where they're actually launching web apps, they'll be using some of these things. So you have env, which is going to be setting the environmental variables. You're going to have expose, which is going to specify the port that the container should listen to when it runs. There's copy or add, and these can add files to the container's file system. And then cmd, which specifies what basically is the default command that should be run when a container executes. And there's more than this as well, and so I'm pointing you here to the Dockerfile reference that gives you more commands in this. But to be honest, most of you will end up just using these first 2 commands in your Dockerfile for this course. And these ones may exist in the base images that you use, but you might not have to edit them or interact with them really. Now, similar to other things in science, when we are choosing a base image for our Dockerfile, we really should stand on the shoulders of giants, okay? There are teams out there who is part of their job is to create really great images for different aspects of tech. And there are teams that are creating great images for data science. So a couple of the teams, for example, is the Rocker organization. So those are from our images. We have the Continuum team. They're the folks who make Anaconda and Miniconda. And so they have a whole bunch of images that they craft and make available, as well as the Jupyter Core team. They have a bunch of images available for Jupyter related in both R and Python software. So I really encourage you to embrace what others have done before you. Don't feel like you need to create a Dockerfile all the way from Debian or Ubuntu, from the base operating system up. Really do go ahead and use other people's images. They may have a few extra things that you don't want or don't need, and if you really want to be pedantic about that, you could take their Dockerfile and remove the things that you don't want or don't need, as opposed to trying to build this all from scratch, at least the first couple times that you do this. So what are some good base images to work with for R or Python? So in the last slide, I kind of pointed these 3 out. So there's the Rocker team, and one of the ones that might be useful for you is tidyverse, because it has a lot of the packages that you're used to using. There's the Continuum ones, and Anaconda 3 would have a lot of the scientific Python packages involved, and same thing with the Jupyter SciPy notebook ones. They all might They all have slightly different run commands. I think I've demonstrated to you how to use the Rocker ones and the Jupyter ones, but they all have documentation that will tell you specifically how they should be run, so you can get that up and going. So for a couple of you folks, you're mixing the languages between R and Python, and so here, for example, this Rocker Tidyverse one was only R, and this Continuum Anaconda one is only Python. Well, what do? Can you like put two images together? And so the more straightforward way is to think about your project and say, like, well, is there more R dependencies or more Python dependencies? And if there's more R dependencies, I might go towards a Rocker image and then layer on some Python stuff. So I've actually done this here, and I linked to it for you here. And then there's some images that are already kind of set up to work well with both languages. So here I'm linking to the Jupyter SciPy notebook, but there's a Jupyter R notebook that has lots of packages from R as well as Python, and so you might want to take a look at that. The Jupyter team has given us nice tour to Docker images that they make, and so if you click on this link here, it lists all of the different Jupyter images that they make and gives nice short descriptions and what packages are installed, so it makes it easy to select for you. And to round off the lecture, I'm just going to quickly answer a few frequently asked questions about Docker files from past years. So one is, where does the Docker file live? So generally, if you have one Docker file for a project, it makes sense to just put it in the root directory of your project because it's very easy to find there and very easy to build from there. You don't have to worry about specifying a path. If, however, your project is more complex and you have multiple Docker images for different, or Docker files for different Docker images for doing different tasks, then sure, these would go in subdirectories, but then when it comes to build time, you have to remember to point to the right Docker file. How do you make a Docker image from a Docker file? So there's two ways to do this. So in this lecture, what I do when I'm first developing a Docker file to make a Docker image is build the Docker image locally on your laptop using Docker build. Now, the second thing you do is building an image using a trusted piece of software. So a tool that I was using up until, I would say about 6 or 8 months ago, was automated builds on Docker Hub. And again, I'm going to get rid of Docker Hub here, GitHub, to GitHub Actions. So I have recently moved to using GitHub Actions to do my automated builds for Docker images because of two reasons. One is that it is, how would I say, faster, I find. And then the second reason is that I have more control over when the automated builds are triggered. And I like to only trigger the automated builds when I'm editing the Docker file on the main branch of a project, okay? So if I'm over here on another branch, some sort of patch, and I'm editing, I don't know, a Python function, and it has nothing to do with Docker, and I push that up to GitHub, I don't want to trigger a build of my Docker file because nothing's changed in the sense of my Docker file. I only want to trigger that build when I am editing the Docker file and when I'm pushing that to main, because I have like decided that yes, this is like a change that I want to be part of the main part of the project. So that's the main reason that I have those. That is, I guess, probably the main reason, more so than speed, that I've moved to using GitHub Actions to control the automated builds as opposed to using Docker Hub. And how do I build my Docker image locally on my laptop? So we went over this earlier, but this is something that's easy to forget. So Docker build --tag, and then you say what you're going to call the image. And then if you want to give it a version, you don't have to use tagging when you're doing it. I didn't, but if you would like to, you say colon and then the version, okay? And then finally, you have to say like, where is the Docker file from where you're building it? In today's lecture, it was in the same repository or the same directory that I was in, so you can just put dot. But if it's somewhere else, then you have to point to that directory. And the final frequently asked question is, how do I know what commands to use to install things on Linux? I went through this myself because I am not a Linux operating system person on a day-to-day basis. I use a Mac, so this was very foreign to me when I started doing this. So one place that is helpful to start, because a lot of the tools you'll be wanting to put inside of your Docker image are ones that are currently on your laptop, is looking at the MDS Linux install instructions. So I've linked to them for you here. And then the second place is that sometimes there are things that are a little bit different or more specialized. And so another place to look is how people are doing this in other Docker files. Okay, so I would say that it's always really useful to look at demos or examples of things that you would like to emulate. And so you've been doing that, I think, a lot in this project by looking at, for example, the breast cancer predictor project and looking at different aspects of this. So there is that one example for the Dockerfile, but I wouldn't limit myself to that. If I were you, I would look at many of them so you can kind of see how things generalize, and look at different strategies that you identify more with versus another. And we'll get into some more details about specifying package versions and Docker image versioning in the next lecture, okay? So we're just starting to get going with building and crafting our Docker files to build Docker images, and we'll continue to learn this stuff next lecture. So the learning shouldn't be over yet. Okay, so what's next? So I just hinted at that. So we're going to learn some best practices for package and container versioning in our Docker files, and once we build them and build them automatically on GitHub Actions. We're going to learn how we can run things non-interactively using the command line from our Docker file. So a lot of what I've been showing you is using these containers interactively, but they are also very useful to run them non-interactively. And then we'll do a wrap-up of reproducibility and data analysis projects.